Still looking at the same example, 7.2 number 40. In the last video we did part A. Now we'll do part B. What is the probability that a randomly selected car will spend more than 160 seconds in a Wendy's drive-thru? We can describe it in this way: the probability that x is more than 160. One way to find this is using a calculator. Like before, you'll use NCD on the Casio, normal CDF on the TI-83 and 84. I'm going to draw a curve. Mean was 138.5. Remember that on the curve, the x values are getting smaller on this side. If we were to go forever in this direction, this would be going towards negative infinity. If we were to continue to the right in this direction, we'd be going towards infinity. And 160, we want to find the chances that x is more than 160. 160 is going to be somewhere up here. So that shaded part, it's going to be the answer to this probability. On the Casio, you would use NCD. Again, it's going to ask you for the lower bound, the upper bound, standard deviation, and mean. This time, looking at that shaded region, the lower bound would be 160. Lower bound is always the left part of the shaded region. 160. The upper bound is always the right side of the shaded region. And in this case, the shaded region just goes forever in this direction. It doesn't really have an upper bound, so we just say that its upper bound is infinity. And you'll put 10 to the 99 power. On the other calculators, use normal CDF. Lower bound is 160, upper bound is 10 to the 99. And the result comes out to 0.2292. 0.2292 is also the area of that shaded region. So remember that the area of the region under the curve is equivalent to a proportion and also equivalent to a probability. Another way to solve this problem is to use Table 5, the normal probability table. It helps to draw the curve. The first thing is to find the z-score. This time our x is 160. Plug in all the values, and the z-score comes out to 0.74. And like before, we've converted our probability so that it's no longer in terms of x, but now it's just in terms of z. The probability that x is more than 160 is equivalent to finding the probability that z is more than 0.74. We'll go to the table and look up a z-score of 0.74. Here's the 0.7, and then we need to find the 4, so here's the 4. So 0.74, look to see where they line up, and it looks like they line up at 0.7704. That number is not exactly what we're looking for. Remember that all of those areas in the middle represent the area under the curve to the left. And in the drawing of our curve, we wanted the area to the right. So that 0.7704, that's this side of the curve, 0.7704. To find out what's the area on the other side to the right of that z-score, you find the complement. We can do 1 minus 0.7704, which is 0.2296. That's the area that we're looking for. It's written out right here in a little more detail, but ultimately we'll get the probability of 0.2296. And note again that there's a slight difference between the answer that we got using the table and the answer that we got using the calculator. 0.2292 versus 0.2296, but that's okay. There is going to be a slight difference because when you're using the calculator, you will likely have to round off the z-score, and that results in a slight difference in your answer. Part C asks, what proportion of cars spend between 2 and 3 minutes in the Wendy's drive-thru? There's something that we'll have to do first before moving on with this one, and it's that they're asking this question in terms of minutes, but the rest of the parameters have been in terms of seconds. So the first thing is, instead of writing it as 2 and 3 minutes, we'll just do a quick conversion and change that to 120 seconds and 180 seconds. So ultimately, this is the probability that we want to solve. The probability that x is between 120, which is 2 minutes, and 160 seconds. One way to find this is with a calculator. It always helps to draw out the curve. .120 is somewhere down here. 180 is somewhere way up here. We want to find the probability that a car would wait between those two amounts of time. So this time the shaded region is between 120 and 180. The actual value of that shaded region is whatever this value is, of x being between 120 and 180. This time, when you use NCD on the Casio, your lower bound is going to be 120. That's the boundary on the left. The upper bound is going to be 180. That's the boundary on the right. When you use normal CDF on the TI calculators, same thing. Your lower bound will be 120, your upper bound will be 180. When you plug those all in, your result should come out to 0.6620. The other way to work this out is to use a normal probability table. Draw the curve. 120 was somewhere down here. 180 was way up here. We're trying to find the area between those two values. The first thing, again, is to calculate the z-scores. This time, there are two numbers we're dealing with, 120 and 180, and so there are two z-scores to calculate. Here's the z-score for the lower bound. Plug in 120. That z-score comes out to negative 0.64. Here's the z-score for the upper bound. Plug in 180 and all the other numbers, and that comes out to 1.43. And like before, this is just converting our probability so that it's no longer in terms of x, but now it's just in terms of z-scores. We're trying to find the probability that z is between negative 0.64 and 1.43. Go to table 5, look up both of those z-scores. Let's start with negative 0.64. Here's negative 0.6, here's the 4. Let's see where they line up. And it looks like they line up here at 0.2611. We'll find the value for the other z-score, 1.43. Here's 1.43. It looks like they line up right here at 0.9236. Keep in mind that these two values that we got, they represent the area under the curve to the left. Here's our curve. That first value that we got of 0.2611 represented the area to the left of that z-score. The other value that we got, 0.9236, that also represents the area to the right. To the left. So it represents this whole entire area to the left. 0.9236. But we don't want this entire area to the left. We only want this spot in between. So what you can do is subtract 0.9236 minus this overlap right here of 0.2611. When you subtract the two, you end up with 0.6625, and that represents the area in between that's left over. So I guess the lesson is that when you want to use a table to find a probability of x being between two numbers, you'll have to find two z-scores, find their areas, and then subtract those two areas.